All right. Let's start with our lesson for the day, wherein I'm going to introduce a new topic, an interesting one. So it's called analytical geometry. So that's where you must score higher marks because it's a very simple topic. It's simple to understand, and even the questions are simple to answer. So the topic is called analytical geometry. So now, on analytical geometry, it's when we are dealing with points that are in Cartesian plane, like this. So let's give as an example, we are given 2 points. So the points, they are also called the coordinates. So let's say we have a coordinate here or a point there, which must have an x value and the y value. So the first value is x value and the second value is the y value. So we start with x and then we end with y. So here we are saying x1 and y1 because we are having the second value, which is x2, y2, like that. And then let's draw a line in between these 2 points. Let's draw a line in between these 2 points here. So if we draw a line in between the 2 points, so one can question of how we can measure the distance between the two. How can we measure the distance between the 2 points? That's the first question we're going to answer, of how you can measure the distance between the 2 points. So let me just give an example. So if we want to measure a distance from where you are right now to Gauteng, or let me say to Joburg at Park Station. So how can you measure that distance? So I will be answering such kind of questions with this chapter today of how you can measure the distance between 2 points. And then the second question will be to measure the gradient, of which the gradient is the same as a slope. So if we want to measure a slope, how high or how steep is the place. So you are going to use what is called the gradient formula. So you are going to use the gradient formula of measuring the steepness that is there. How steep is this 2 points, the steepness between the 2 points. So that's the second thing which I'm going to cover with you. And then the third, we are going to measure what is called the midpoint formula. So the midpoint is for measuring a middle point between these 2 given points here. So I will give you a formula that calculates exactly the middle point between these 2 given points here. I can give a scenario again. If we want to measure where exactly is at the middle between exactly the point where you are to Joburg Park Station, where exactly do we have the middle point? So we are going to use what is called the midpoint formula to measure those things. So mathematics is applied in real life. So you can see I'm trying to give example by real life situation of which we do apply in many different cases. So it's important for us to answer such kind of questions. For example, if we answer a question of how far is between the region where you are to Joburg Park Station, you may find that it solves many other problems that are there in real life situations. So I'll give you more examples when we go on and on this chapter. So now let's start with the first important formula, which you must take note of which is called a distance formula. So before I give you the formula, I would like to find out if you have done distance formula from your school already. Have you done distance formula from school already?
Yes.
All right, wonderful. Nikiwe, have you done the distance formula from school as well? It's Nikiwe. All right. Let me find out from Adi as well.
Yes.
All right, wonderful. So it means I don't have to explain much then. If you have done this, let me just remind you, and then from there we use them on the questions. So a distance formula is given by this formula here of d, which stands for distance, and then x2 minus x1, it must be squared, plus y2 minus 1, y1, and then squared. So that what represent a distance between 2 points. If you want to calculate the distance between 2 points, then this is the only formula you can use. I can tell you without any hesitation that this formula here, we use it even at the university level. So you are using it now in grade 11, you will use it in grade 12, you will use it when you go to university, and you will use it when you are working. If it happens that you work in engineering field, mathematics field, finance field, all those things, they need a distance formula because it's the only formula in the world to measure the distance between the 2 points. We don't use a ruler, but we use a distance formula to measure the distance between 2 points. So, and that is the formula that we have there. So you must know this formula by heart from now until you go to university. So remember the x2 is the x coordinate on this point here, and x1 is the x coordinate on that point. Same with y1 and y2. And then from there, we go to the second interesting formula, of which let me start with midpoint formula. So remember that the midpoint formula, it measures the distance between the 2 point, the midpoint between these two given points here. So now to measure the distance between the 2 points, we're going to use capital letter M. Midpoint is represented by capital letter M, of which it must be equal to x1 plus x2 divided by 2, and then y is y1 plus y2 divided by 2. So this is the only formula which you can use to find the point which is at the center between two given points. Let me show you the scenario which I'm talking about. So this is the point where you are, and this is Joburg Park Station. So if we want to know where exactly is at the middle between these two places, you are going to use midpoint formula to calculate exactly the region where we have a midpoint, or where is a middle at the center between those two regions. So we use midpoint formula, and there's no any other formula that calculates the midpoint beside this midpoint formula. So the number 3 is the most interesting one. I've explained the distance and the midpoint, but the third is the most interesting one. It's called the gradient. This is called the gradient formula. I can tell you that when you go to grade 12, you are now at grade 11. When you go to grade 12, you are having a full chapter which comes with a lot of marks that deals with this formula, which we call a gradient formula. Even when you go to university level, you no longer do Euclidean, you no longer do analytical geometry, you no longer do financial mathematics, you do at grade 12. You will be dealing with this gradient formula because it's very important. It does a lot of things. So the gradient formula. So let me introduce the gradient formula to you, the one you use at grade 11 and grade 12. You use this gradient formula, which is represented by small letter m. Here we use capital letter M, and down here we're going to use small letter m. Is the one which represents gradient. So m is equal to y2 minus y1, all divided by x2 minus x1. So this is the formula which can calculate the slope or the steepness or the gradient between 2 points. So you can use this formula. So at times, you may not be given the 2 points like this. You may not be given a 2 points like this, but you may be given an angle that shows the steepness of the graph. So if you want to calculate the gradient, you use this second formula. That is the first formula, and then the second formula is the gradient, which could be given by tan of theta, where theta is this angle here. So you can use either this formula or you use that formula there. Let me find out if we are together before we move forward. Okay, let me do it like this so that you can see that last formula I wrote there. So are we together up to so far regarding the 3 formulas I have introduced to you?
Yes.
All right, wonderful. And then from there, we are going to formula number 4. So formula number 4 is for calculating what is called the straight line equation. So if you want to calculate the straight line equation, I would like to explain what is a straight line equation. So straight line, we are referring to this line here, this line that we have here. So we must be able to find an equation that represent this line here. So, and I can tell you, we have to use a straight line equation in order to represent a given like that. Because you may have another line which goes like this. How can we represent that? Another line which goes like this. How can we represent that line? We can represent all these lines we have on the board by using straight line equation. So, and the straight line equation is given by 2 important formulas. The first one is this one of y, which is equal to mx plus c. That is the first formula which you can use to represent any straight line. As long as it's a straight line, it can be represented by this. But if it is not a straight line, let me give an example. That is a parabola. So a parabola is not represented by this one because this equation only represents the one, the straight line. So I'm explaining in detail today so that you never forget this. I'm explaining important formulas which you must not forget even a single day. So on this straight line equation, we have what is called the dependent variable, of which the dependent variable in this case is y. I will explain in detail why do we call it a dependent variable. We also have an independent variable, which is called x in this case. So x is the independent variable. I believe by now you know what is m. We talked about it here. So that's why it's important. You can see it's now being used in the formulas. So m, it represents the gradient we talked about in the previous formula. And then we also have a c. So that c is what is called the y-intercept. So what is y-intercept? So y-intercept, we are referring to a situation wherein we're having a straight line. Let me give an example by this straight line here that we have. So at this point where the graph cuts, the y-axis is where we call the y-intercept. So the y-intercept is where the graph cuts the y-axis. The x-axis is where the graph cuts the x-axis at this point. So I will talk more about these points at later stage. So, but for now, you must take note of the fact that the y-intercept, which in this case is represented as C, it's where this straight line here cuts the y-axis. And then the x-axis is where this graph here has the what? The x-axis. Take note of that. It's very, very important information. So we have the dependent variable, the gradient, the independent variable, and then the y-intercept. Now you know how to find the gradient. The gradient we find by using one of these two formulas. And then the dependent variable, we call it a dependent variable because it's depending to the values we obtain here on x. So it's only when you substitute the value of x where you will be able to have the value of y. So that's why we call it dependent variable, because it's depending to what? It's depending to x. And this we call it independent because it's not depending to any variable. You may be given, if you're having a Cartesian plane like this, you must be given x values. And once you're given the x values, you can then be able to calculate the y values. And I've explained already about the y-intercept, but I will elaborate further at later stage. So this is the first formula which you must know, né? And now let me give you the second formula, which do exactly the same thing, which calculates the equation of a straight line. Is this first formula, and then the second one is this one of y minus y1, which is equal to m into x minus x1. So where is the difference between the two formulas? The difference is that in this case, we are not having the y-intercept on the second formula, but the gradient is there, the dependent variable is there, and the independent variable is there. So it's only the y-intercept which we don't have. But in a place of y-intercept, we are now having x1 and y1. What does x1 and y stands for? It stands for any of the points which you can be given along this straight line here. For example, we have this point of x2, y2, and we also have this point of x1, y1. Therefore, you can substitute them into this formula, and then you can be able to calculate the equation of a straight line. Then from there, let me talk about the y-intercept and the x-intercept. I will start with the x-intercept. So at the x-intercept, let me write it here. At the x-intercept, always the value of y is equal to 0. This does not change. At the x-axis, y is equal to 0. Remember, at the x-axis is exactly on top of this line here, which is our x-axis. So on this line, the value of y is equal to 0 at all time. Take note of this important statement because you're going to come across these questions that deals with the situation we have here. Let me wait for Nikiwe to come back because I don't want anyone to miss any information from what I'm explaining here. Because if I explain like this, when we do questions, you will never have any problem. So as I was saying, we have x-intercept, which we get when y is equal to 0. We also have at y-intercept. So it's vice versa. At y-intercept, x is equal to 0. At x-intercept, y is equal to 0. So those are important information which you must take note of. So we have 1, 2, 3, 4 formulas. We also have the last one, which I want to show you. All right, Nikiwesh is back. I only explained this last formula here, or let me say last expression, which talks about a point, the x value at the y-intercept. So the x value at the y-intercept is always equal to 0. And then from there, let me also talk about when we are having lines which are perpendicular to each other. So you may find that you're given this straight line like this, and then you are given another straight line like this. If this straight line here is having a gradient m1, and this other straight line is having gradient m2, If we are given that these two lines are perpendicular to each other, perpendicular, let me say perpendicular straight lines. So you must know that perpendicular straight lines, when we multiply their gradients, they must be equal to -1 all the time. This does not change. As long as these two straight lines are perpendicular to each other. Perpendicular is when there is 90 degrees when we measure the angle between the two straight lines. If these two straight lines are perpendicular to each other, when we multiply their gradients, they must be equal to -1 at all times. So take note of that important statement. And then from there, formula number 6 is very popular for you. It's what is called Pythagoras theorem. I believe you know this formula by heart. So you must remember it even on this chapter of analytical geometry. So we'll be having x squared plus y squared, which is equal to r squared. So we will use Pythagoras theorem even on this chapter. So otherwise, I've summarized this important chapter for you. And I don't think I left anything. Otherwise, if there's something that I missed, I will explain to you when we do examples. So otherwise, I would like to ask you to give me questions under this chapter. I don't want to do questions from my side. I would like you to bring questions for analytical geometry, and we'll do them together. We still have time where we can cover questions. So just find questions for me, and then we'll do them on the board together. So let me rub off what we have here, and then we do questions that you're gonna send to me. Wonderful. We received a question from Nikiwe. Let's do these questions together. Let's do the questions together. So now we will do question number 8 and question number 9 as indicated on the questions she sent. So we are given a point or a coordinate of 4 is to 8, and then F, which is -2 is to 5, and G, which is -1 is to -3, and H, which is 2 is to b. And we are told that these are the 4 points in a Cartesian plane. These are the points on a Cartesian plane. So now the first question requires us to determine the gradient of EF. Let's determine the gradient of EF of this and that. So whenever you hear about this word gradients, you must remember the two formulas I gave you today. So the first one is this one of m equal to y2 minus y1, all divided by x2 minus x1. And then the second formula is that one for m equal to tan of theta. That is what you must remember first. And then after having that, you must have a skill of choosing which one are we supposed to use between the two. So in this case, we are given the coordinates. When we are given the coordinates, we must use the first formula. When we are given the angle, it's when you must use the what? The second formula. So in this case, we're going to stick with the first one. So let me rub off the second formula. So now, what matters is how do we use the second formula. You can name these coordinates first before you apply them on this formula. So this one, you can name it x1, and if that is x1, therefore the second one, it must be y1. And then here we have x2. If that is x2, it's a must that the second one must be what? Must be y2. Let's substitute this information into our formula. So we're going to have m equal to y2, we have it as 5 there, minus into y1 is negative 2, all divided by x2, which is negative 2, minus x1, which is 4. That means we're going to have 5, negative times negative is positive 2, all divided by negative 2 minus 4. So we can add these two numbers. We're going to get 7 divided by negative 6, which is the same as negative 7 over 6. And that is the gradient. That is the gradient of these two given points or given coordinates. Let me know if we are together. Did you all understand how we have answered the first question there?
Yes.
Wonderful. So let's go to the second question, which talks about give the gradient of GH in terms of B. So we need to calculate the gradient of GH, but in this case, we are told that the gradient of that, it must be in terms of B because B is not given. So this is what we do. So we say this is X1, that is Y1. This is X2, and that is Y2. And we substitute them into this formula of Y2 minus Y1, all divided by X. Why are we using that formula specifically? Because we are given the coordinates, not the angle. In some cases, you'll be given angle. So you must take note of this all the time. And then Y2 we are given is B, and then Y2 is B, and then Y1 is what? No, let's go back here.
Negative.
So let's go back here. There's something wrong I've done here. There's something wrong I've done here. So where we have Y2, we substitute 5. And then where we have Y1, what do we have to substitute? We have to substitute 8. Sorry about this.
8.
Yes, it must be 8. And then X2, where we have X2, we substitute negative 2. And then where we have X1, we substitute 4. Therefore, that is correct. So let's simplify this. We're going to have 5 minus 8, which is negative 3, all divided by negative 6. So this is 1 over 2. So that would be the answer of this question here. I made a mistake. Instead of substituting 8, I substituted other thing else here on y1. But I corrected that mistake. So we are now having a gradient of which gradient of EF, you can write it like this. It's allowed to write your gradient in that form. So let's do the same on the second one. So we're going to have M GH, the gradient of GH. So it's going to be B minus -3, all divided by 2 minus into -1. So let's simplify. We're going to have B plus 3, all divided by 2 plus 1, which is B plus 3, all divided by 3. And that is the answer we were looking for on that question. We were looking for a gradient of GH in terms of B. So you can see the gradient of GH is in terms of what? Of that B given there. So the next question is the most interesting one. It says, determine the value of B if we are given that FE is perpendicular to GH. I've talked about the perpendicular lines from the introduction I gave you. We talked about the perpendicular lines. What do we know about perpendicular lines? So if we're given perpendicular lines, when we multiply their gradients, so the gradient of EF multiplied with the gradient of GH, they must be equal to what? -1. That's where we start. If we're given the perpendicular lines, you must know the gradients of those perpendicular lines. When we multiply their gradients, they must be equal to -1 at all times. Then here where we have gradient EF, we must substitute a half. And then where we have M gradient of GH, we must substitute B plus 3 over 3. And this must be equal to -1. So what is left from there is just to simplify. We need to simplify this. So this one, it must multiply that numerator. We're going to have B plus 3, all divided by 2 times 3 is 6. And this is equal to 1. And then from there, we can cross multiply. When we cross multiply, we'll have B plus 3, which is equal to 6, because 3 times 1, 6 times 1 is 6. We take this 3 to the other side, we'll have B, which is equal to 6 minus 3, and that is equal to 3. So the value of B in this case is equal to 3. B is equal to 3. Let me know if you all understood how we got to the final answer on that question.
I understood.
All right, wonderful. Then we have answered question number 8. We can then go to question number 9. And unfortunately, this is just a repetition of what we have done. So just to show you understand what I've done with you, may you please try and do question number 9. Yours is exactly the repetition of what we have on the board. So you can try to do question number 9, and then when you are done, send that to me immediately. I will then correct you if you struggle to get the correct answer. So it's now your turn to do that question number 9.
No.
Hello?
Baba could read number 9 is kana after lesson.
Yeah, you can do immediately. You can do that question immediately.
Okay.